All right, one thing that we have to try to learn on our road to understanding limits is the idea of the absolute value function and its use to express a distance from a particular point. So, let's say that we had an interval, and let's say that this interval was any value between -5 and 5. Right? There's a couple different ways of expressing that. Since I said any value between and not including, we would know that this is an open interval, right? And we would indicate that with little open circles instead of closed circles. So that's why we call it open interval. One way to write that would be to draw out a number line and indicate where they would be. The endpoints would be, and shade in the interval in between them. Another way is similar to the coordinate pairs notation of including it inside of parentheses, but usually it's followed up by the word the interval of -5 to 5. We could also write it with inequality signs, right? So we would say -5 is less than x and is less than 5. This gives us the idea of expressing with positive and negative signs direction of left or right. And if we were to rotate the number line by 90 degrees, it gives us an idea of up or down. But what if I don't care about the direction, and all I care about is the magnitude of the distance from some center point? In our case, our center point is 0. So this number interval can express a distance from some origin point. One way that we can do it is with an absolute value function. And if you recall, an absolute value function, if you put in a negative number into it, it returns back a positive number. And if you put a positive number, it just returns back whatever that number is. So it's the same number, but without regard to its sign. So there's a couple different ways of defining an absolute value function. One of them is a piecewise function. So if x is less than 0, then multiply it by a negative x, multiply it by a -1. So if I give you a -5, multiply that by a -1, and you get +5 out. Another way of defining it is take whatever the number is and square it, because if you square any number, it becomes positive, and then immediately do the inverse operation of taking a square root, and that will take the positive square root and don't return the negative square root, and we would indicate that with a little plus sign right before the square root. Another way to do it is just by common agreement between two people, right? We say maybe a little plus sign, just like we do with the square root, maybe with a circle around it, and say that means take the positive of x. Generally, we don't use this notation because sometimes maybe someone would forget the plus sign. And in general, the absolute value of x is not equal to x itself, because if I put in the absolute value of a -9, that's a +9, but +9 is not equal to -9, right? So that just reinforces what I just said. So just like I said before, we can think of these intervals as being centered about some number, right? So in the case of -5 to 5 in that interval, our center point is 0. And we can think of the whole distance between the endpoints as the total distance of the interval, and from the center point we get these half widths of the interval. So the total interval from -5 to 5 is 10 units long or wide, and it's half of that to either side of your center point. We can also use the absolute value sign to check whether or not a number is, or the absolute value function, we can use that to check whether or not a certain number is inside of an interval or not. So the absolute value, for example, of -3, which would be right here, is 3, and since 3 is less than 5, right, then -3 is inside the interval. We could take the absolute value of a +4, right? So this was -3, this is a +4. And since the absolute value of a +4 is 4, and 4 is less than 5, then that resides in the interval. We could take the absolute value of a -6, right? Returns out a +6, and a +6 is not less than 5, so we would say that that is outside the interval. We could take the absolute value of a +6, get out again a +6, and same case as with a -6. So, taking the absolute value of a certain number and having that be less than the half-width of an interval is logically equivalent to saying whether or not a number is within that interval. So that's great if everything was centered right at 0. But a lot of times we want to express intervals that are centered about some arbitrary number. So for example, let's say that I wanted to express an interval that was between 20 and 30, right? I could think of this interval as centered about 25, right? So 25 is right in between 20 and 30, and 20 is 5 units to the left of 25, right? And 30 is 5 units to the right of 25. So this is very similar to our interval that was centered about 0, but it's shifted to the right by 25 units. So one way of thinking about that is rewriting it a little bit. So we can take this interval of x, or 20 less than x less than 30, and rewrite 20 as -5 plus 25 less than x less than 5 plus 25. So here's that shift, right, of the plus 25 that we see geometrically here. And one thing that we can do is, in our inequality, subtract 25 from each portion of our inequality. So I'll subtract 25 from here, and subtract 25 from here, and subtract 25 from here. And I'm doing the same thing in each one, so therefore the inequality should hold. And what I get is that -5 is less than x minus 25, which is less than 5. This is the same thing as what we kind of saw up here, only instead of x, we have x minus 25. So this is actually logically equivalent to writing the absolute value of x minus 25 is less than 5. We can abstract this out and say that if I want to express a interval centered about some number with a particular half width, I can say the absolute value of x minus c is less than w. If I want a closed interval, right, versus an open interval, instead of having just a less than symbol, I can have a less than or equal to symbol. So our C here becomes our center point, and our W is our half width. Okay, so for example, if I wanted to express the closed interval of -5 to 5, I can think of that as my center point of 0 and a half width of 5. I can think of an interval from 20 to 30 as having a center point of 25 and also a half width of 5. What about negative center points? So for example, if I had an interval from negative 20 to negative 10, I could write that as having a center point of negative 15 and a half width of 5. So I would write that as the absolute value of x minus c, and c in our case is negative 15, and that's less than or equal to our half width of 5. So here, if we have the absolute value of x plus 15, negative times negative is positive, less than or equal to 5, it's the same thing as that interval. We can see that as taking the reverse approach. If x plus 15 is any number between negative 5 and 5, right, it'll be less than or equal to 5. And then we kind of do the reverse process to get back to the expression in the form of an inequality. So let's say that we wanted to go back and forth between an absolute value notation of an interval and the actual interval itself, and then reverse if, let's say, we had an interval expressed as an inequality and we want to put that in the form of a absolute value function expression in an inequality. So we can look at this, right? And from here we see, here's an example of absolute value of x plus 2 less than 3. I can see that my c value is equal to negative 2. Why is that? Because our c value is written right here. And if I have x plus 2, it's the same thing as x minus negative 2, which matches the form that's written right there. And my width is 3. So I know that I have a center point of negative 2 and a width of 3. So 3 units to the left of negative 2 is negative 5, and 3 units to the right of negative 2 is negative 1, 0, 1, right? So the x can be any number greater than negative 5 and less than 1. Let's say that I wanted to express the interval between negative 6 and negative 5. Well, I would first find what my center point is, right in between negative 6 and negative 5, which is negative 5.5, and find the distance in either direction of that, which is 0.5. Right, or 1/2. So I could write this as x minus a negative 5.5, which is plus 5.5, is less than 0.5. Okay.